Hi everyone. In our last video we talked about the purpose and function of anti-telescopic devices, ATDs, and blank end plugs. An integral part of these components is the sealing mechanism. Now we want a good sealing mechanism on these components to ensure a high level of segregation between the concentrate or the retentate stream of a membrane process and the permeate stream. Without a good seal, the system may fail to effectively achieve its concentration factor, or the plant yield of the desired component may end up being very low. Now, good sealing is really important when you have a high value protein stream, or the permeate stream needs to be to a high purity, such as recovered polished waters for reuse in dairies. You need that stream to be as pure as possible. So good sealing of the components, also the segregation of components through good sealing, is an absolute must. In the previous video we discussed membranes are installed in series with an ATD or an interconnector in behind each membrane, membrane 1, 2, 3, etc. One thing of note is the ATDs and the blank end plugs are either made with a lip seal center core profile or an O-ring center core profile. You can't adapt one component to suit a lip seal and then or an O-ring. So it's just a point that some of you may not be aware of. Smart Membrane Solutions predominantly manufacture and supply lip seals, and we manufacture both an EPDM and Viton. They're both certified for EU and FDA food contact approval. Viton, which we colour a red-orange colour in SMS, is a high quality synthetic rubber used in applications where resistance or high resistance to chemicals is required. We recommend using Viton in ultrafiltration applications that are using sodium hypochlorite as part of its CIP or its cleaning regime. EPDM is a high density synthetic rubber and is recommended in reverse osmosis and nanofiltration processes where chlorine will not be being used in those cleaning regimes. The EPDM material is generally slightly more cheaper than the Viton material. There's extra requirements in temperature and chemical resistance in this particular seal. A few advantages and disadvantages. Lip seals have an overall larger surface area, allowing the component to have a greater surface area contact with the permeate tube. So it also allows for better sealing integrity. And if you've got a plant that has high shaking or high vibration, such as upon startup of a plant, you generally find that the lip seals are more forgiving than the O-ring components. Plants running high product viscosities and also high protein concentrations, or high pressure, high protein concentrations. Also, we would recommend running a lip seal configuration against an O-ring. You can run O-rings if you've got a low pressure environment that is running very low viscosities. And O-rings generally can be fine. You certainly want just good stability and really good control around your plant. So any movement in your vessels of your membrane train will often reseat, if they do make some disconnection, often reseat better with a lip seal configuration if there is some movement. So the extra surface area does allow some forgiving aspects to the membrane operation. Some of the common issues that we've seen in our experience from the plants we've seen, clearly the biggest issue we see is yield losses, or losses of the targeted component species being lost to permeate. So plants struggle with yield. So generally you've had a loss of an O-ring or a lip seal from your component. Plants struggle to achieve, if they're making a high protein WPC, 80% for example, or high protein NPC, sometimes we see plants struggling to achieve their protein levels due to low concentration factors as a result of seal failures. Sometimes we see with O-ring plants, the O-ring will roll off the end of the ATD, and sometimes there's been a disconnect in the plant and it's jammed back on, and the O-ring has come adrift from the profile of the ATD. So that's something that we do see now and again. So we've certainly endorsed with high value protein streams that the lip seal configuration is used. Now I just wanted to demonstrate that when fitting these components, sometimes we see that the O-rings are more prone to rolling off the center core of the component within the permeate tube that you can see there. So you get a buckling effect, and the O-rings clearly do not sit correctly on their profile, and that will evidently lead directly to failures. So here you see the O-ring sealed inside the permeate tube, a lot less surface area or opportunity to get good contact and good sealing against the inside surface of the permeate tube that sits within the membrane vessel or within the membrane element. So you can see here that the lip seal surface area coverage around the inside of the permeate tube is quite extensive when you compare that to an O-ring. So it gives you a bit more assurance of the separation between the retentate and the permeate. So there you have a brief overview of membrane component seals. If you have any further questions or you'd like Smart Membranes to assess your current equipment at a site in the ANZ region or elsewhere in the globe, then please contact us directly. Please click further below here to download our latest product brochure and parts list, or contact us directly for more information.